If we now look into the steps that what you could do and what could be avoided, could be these. First is focusing on understanding the concepts. So this is really very, very important. The more you understand the concepts better, the more you'll know where those things could be applied. For example, if there is an algorithm, if you know exactly how it works, then it will help you uh, sort of prioritize or select what particular algorithm might be best suitable to for a particular task. I'm not saying you need to derive or uh, do the math for algorithms, but you uh, uh, knowing how it works and uh, uh, what it how it works and why it works, it will help uh, in implementing those methods for a particular task. Continuous learning is important as this field is rapidly growing. There are new research papers published every single day, and you'll hear in news there are new products coming up, new methods coming up. So, continuous learning is very, very important. And for now, if you are starting, I'd suggest starting out with Python. Language would be one of the ways you could get into this field. Then practicing coding. Given that there are now AI tools that can write the code, and maybe eventually part of the code writing could be done by AI, still I'd suggest that practicing coding now is still important, and it will still remain important because when practicing coding, the task is definitely learning the syntax of how to write the code, but at the same time, another important task that is happening is training to translate your thoughts into a logic that computer can understand. So that style of thinking is what we are trying to develop when we are trying to practice coding. So even if there are advanced methods that later on write the code for you, if you know how, if you are already trained in that logic, maybe it will help you uh, uh, or do things more efficiently. Experimenting with projects is also extremely important. So if you already have taken a course, you have learned the language, if you have learned a particular skill set, and if you have a question, now what should I do? The answer One of the answers could be start experimenting with projects. Write code, start and try and create something, a product that is that does something, right? Or if you do some sort of analysis, arrive at a recommendation based on what data was available and what question that you try to ask in that experiment. Another important way you could improve on your skill is collaborating and networking and working on collaborative projects. These could be competitions. You could work with your team, with your friends or colleagues, and start implementing these newly learned skills on projects. And what that will do is that will sort of bring your skills to test, and not only will it allow you to implement them, but at the same time you'll face so many problems and challenges and frustrations, and that is part of learning that will help you make your already learned skills much stronger uh, and keep that momentum going moving forward. uh, Additionally, I'd also suggest seeking feedback from people who are good at that particular skill, or getting feedback from people who are interested in that area would also help you or guide you uh, in this process of learning uh, coding, learning data science, AI, or ML. So that's another thing that you could do here that's not mentioned is keeping up with uh, uh, recent literature or research that is there. That will be the part of continuous learning. What not to do would be the first thing I'd say is not rely solely on automated tools without knowing the concepts. I know that today there are tools that will do lots of stuff automatically, and that is good. If the interest is to use those tools in future and not dive into the coding part as I showed earlier in the AI ML forest, that would be a better option. But if you are interested in uh, talking with the computer, doing the coding, customizing, having the freedom to perform the analysis on a variety of data, then I'd say relying on automated tools solely is would be uh, something that I would try and avoid. Overlooking fundamental topics is also something that I would avoid. If you are interested in building custom projects that are in the area of machine learning or deep learning, or if you are very serious into uh, analyzing data in space of data analytics as an analyst. So understanding, knowing the mathematical and statistical concepts is also important. Neglecting hands-off practice, that is again no. So anything you do either with automated tools or if you are writing code, practice is really important, and the more you practice, the better you'll be at performing at better at using that method to perform a particular task. And staying in touch with the data science community is uh, equally important, so that you are staying updated with what's happening around you in the field of data science, knowing what algorithms are there, what products are there, what new innovations are there, who is working on what. So all interesting things would be available, and this is easy to do on the online. If you go online, it'll be there. There are lots of free workshops, online seminars arranged by universities as well, or companies. You could attend those, and there are seminars also on YouTube uh, that uh, that are worth watching. Well, and if you fail after doing all of these things, if you fail in certain way, maybe a project, maybe learning to write a, you're spending a month and still cannot understand the concept of what's happening in an algorithm, I think that is a learning process, and it's okay if that happens. uh, One suggestion would be not to give up and keep moving. Maybe set that aside for a while, keep learning other things, and then come back to that later on after you have learned prerequisites for that concept, so that you understand that difficult concept later on. So frustration is part of learning. That's what I think, and so it's okay to fail, but if you learn from it, I think that's a good thing. And stopping learning is something that uh, you don't want to do, because this in this field the technology is evolving every day, and so what is relevant now may not be relevant maybe 5 years from now, 10 years from now. But what would still stay relevant is the math would stay relevant, uh, the the logic of programming would stay relevant, your domain knowledge would stay relevant. So there would be lots of things that get transferred over, but at the same time there will be certain new things that you may have to learn in that time.